I want to talk about how you can control ESP32 over Wi-Fi. So, what does this mean? Basically, you can connect any LED or servo motor or any other sensor to it and just power it up with any charger or any power bank, and you can control your ESP32 board with the IP address which will be assigned to it using your laptop or any other computer. So you don't need to connect it to your laptop all the time like you have to do it for Arduino. You can just control all the movements of LEDs and servos over Wi-Fi. So without wasting our time, let's get started. With the IP assigned to the ESP board, you can send and receive data in real time using WebSocket. WebSocket. That's something new. What is it? Let's search. WebSocket is a communication protocol providing full duplex communication channel over single TCP. The WebSocket protocol was standardized by IETF as RFC blah 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 blah. So now we know it's a protocol. So why don't we use HTTP and we are going with WebSocket? Well, to be short, it's faster than HTTP. Okay, so now since we are done with the approach, let's get into the code. Okay, now first we have boot.py. It has nothing but just connecting to the Wi-Fi logic using network module. After getting connected to the Wi-Fi, we'll get the IP as well, which will get displayed on the console once we'll connect it. I'll show you in a while. Okay, now let's go to the websocket.py. Now here comes our websocket.py. That is the script which has all the WebSocket related code. Here we are importing micro web serve, which is another required library which you will find here, and we are importing it as a module. After that, we have this CB receive text. This is the one where we will going to work. So here this message variable will have the data which we will send over Wi-Fi using that IP. But before we move to this function working, let's go to the servo.py. It has nothing new, but just to make it simple, I've created a class which will initialize the servo motor with the respected pin, and we have a rotate function which will just help us to will pass the angle, and it will help us to move the servo motor easily. That's it. So here, first of all, we have initialized the object, and then we have also initialized the object for LED. That is different. So for this tutorial, we'll only going to work with the servo motor and LED, but you can connect any other sensor and initialize them here. After that, let's move to the CB receive text function. So like I said, this message will have the data. So basically what we'll send in this message is, it will be like this. Message will have the data like this, a string that have either S and let's say angle is 60 degree, or it can have either, if we are controlling light, so it will have L space the brightness, let's say 500. So it will be having this message which we will going to send. The format will be like this. So the reason why I kept this format, I'll let you know in a moment. So S stand for servo and L stand for light. That's how I did it. Okay, after that we are splitting it using space. So wherever it will find space, it will split that and convert it into a list, and that list will have first value as that S or whatever it is, and the second value will be like the value. For servo it will be the angle, and for light it will be the brightness. Okay, so let's go to the if statement, and here we are checking the 0th index. If it is S, then we are calling the servo rotate function. Here it is, and we are passing the angle. The angle is nothing, just the second value, and if it is L, then we are calling the LED object and passing the brightness whatever it is to the this object, this built-in duty object. Okay, and we also have this else statement, which will have nothing but invalid data if the format is not correct. Like if we do not find S1 neither L, that means we are mistaken, so it will print this message. That's it. Other than this, all these values, all these functions you can ignore. These are just like required one. After that, let's move to the main.py. So this main.py is the second script which will start running once this boot.py is done. After, so here we are doing nothing, we are importing this WebSocket library, and here we are calling the start WebSocket function. Start WebSocket, let's look at it. So it is nothing, we are starting using micro web server, so that's what we are doing. It is fine. So once this script will get executed, it will start this WebSocket. Okay, that's pretty much of theory. Now let's move to the practical. Let's see how exactly it will going to work. For this, first of all, you have to copy all these files to your esp32 board. I'll leave the link in the description of a GitHub from where you can clone it to your local and then save it into your esp32 board. And before doing that, you might need to flash MicroPython firmware. For that also, I'll leave a video link in the description. You can follow up that. That will help you pretty much to get started with the esp32. And the benefit of flashing MicroPython firmware to esp32 is you can control and program it using Python like we are doing now. Otherwise, you have to write it on everything in the C programming, C++, sorry, and you have to do it in that way. But since we have flashed the MicroPython, we can use that Python. Okay, so let's move to the practical now. Okay, so I'm done transferring all the files to the esp32. I'm just transferring this last file. Don't get confused with the file name. Here it is WebSocket, it is ws1. That is for my convenience. So I did this for a long time back, so for that reason I kept it ws1, and then I was lazy, so I changed it back. So in the fresh code I have changed it to proper name, so don't get confused. So I'm done. Let's save it, and I think we are done. After that, after uploading all the code, you need to keep it connected to the laptop and press the boot button one time. So what it will do is, it is connecting, and you got the IP, and it is also printing a statement which I added in the main.py. Wait, I'll quickly show you. Let's close this and quickly show you the main.py. Sorry, not main.py, boot.py. Oops, my bad. That's websocket.py, ws1. Okay, so we have a print statement just before we are starting the WebSocket server, just to see if it is getting started properly or not. So that is why it was showing. So you don't need to focus on that. One thing you need to note down is the IP, which is for me is 192.168.1.49. So I'll note that down to my notepad, and after that you can disconnect it, connect to your servo motors. For my case, the servo motor will be connected to pin 23, so I'll quickly do that. and show you how the connection will be, and I'll power this esp32 with the power bank now, and you'll see how we'll be able to control the servo motor movement, also the LED movements with the over Wi-Fi using the WebSocket. Let me quickly finish all the connections and show you. Okay, all the preparation is done. Now we have this client script. I'll also leave this one in this repository into a client folder, but what you have to do is you have to copy all these scripts to the esp32 except that client folder. Let me quickly create it, client, and inside here I'll leave this websc. Okay, so this client folder needs to be stay in your local system from so that you can control it. After that you can just call this create function, create connection to create a connection with the esp32. After that we have a temp list which have the first value is L for light, and the second value is the brightness. So we'll join this list into a string. So for first example I'll show it with the light, how you can control the light brightness. So the brightness is 500. So after that we are sending it using this same object which we created here, ws1, and sending this data, this join data, and if everything goes well then we should see it blinking. Okay, so let's quickly do it and see. Okay, now you can see in your screen I've connected the servo motor and the LED. First of all, let's test the LED. I'll give the value 500 and let's see how it works. And we turned on the LED and it is wireless, so we are sending the commands over Wi-Fi. Let's again turn it off, send the 0 value and run it, and got turned off the LED. Awesome, right? So let's do it with the servo motor now. So the value should be, what was the value? Let me quickly check the WebSocket.py. Yeah, so the first value should be S1 and second value should be angle. Okay, so let's do it. Yeah, so S1 and the angle, so let's give the angle 60 and let's send it. So hopefully should rotate the servo. Okay, we sent the data but we didn't see any output. Let me quickly check what went wrong. Okay, now as you can see we sent the data and servo has started moving. Okay guys, so that's pretty much of it. So hope you guys like this tutorial. If you guys like it, do share it with your friends and to subscribe my channel. I need some subscriber really, and I know I made a lot of mistakes, but I'll improve by time. Okay, till then, bye bye.